I had some questions about question 36 from section 14, so let me show you how this problem has worked. It is Lucinda has 120 feet of fencing to make a rectangular kennel for her dogs. The house is to be used as one side of the kennel. And what length will maximize the area of the kennel? So we have this house drawn with a pin that's right up next to the house. So the house, we don't need any fencing for that. So we have this rectangular drawn on top of it with one side being the length and then the other two, which are equal because it's a rectangle, are the width. But we need to maximize the area of the kennel. So recall that the area of a rectangle is length times width. Well, we haven't worked with multiple variables with functions, and so what we need to try to do is get an expression for area in terms of one variable. And this is where we're going to use this 120 feet of fencing, because that tells us that the distance around this kennel is 120 feet. In other words, that is the perimeter. So we know that the length plus width has to be 120. In other words, the length plus twice the width is 120. This relationship permits me to solve for L. I know that the length then is 120 minus twice the width. So now I'm going to take this expression for L and substitute it into the area formula to get that A is equal to L, which is 120 minus 2W, and then times the width. So the area is really represented by 120W minus 2W squared after I distribute. Well, if I write this in standard form, this is really a quadratic function that is negative 2W squared plus 120W. In fact, because the coefficient of the square term is negative, we know that the function is a parabola that opens downward. And so we do know that there's a maximum area at that vertex. And so we need to find the vertex of this quadratic function. And the vertex is not x equals in this case, but w equals negative b over 2a. And so that's what? Negative b is 120 divided by 2 times a, which is negative 2. So negative 120 divided by negative 4 is 30. Now, it didn't tell us to find what the maximum area was. It asked us to find what length will give us the maximum area. Well, this tells us that the width of 30 feet will give us the maximum area. So to figure out what the length is at that point, we have to plug into our relationship we just found for L, which is 120 minus 2 times W, but W is 30. So in other words, that's 120 minus 60, which is 60 feet. So the length of the pin has to be 60 feet for the area to be maximized. So take a look at this one, think about it, and please let me know if you have any questions pertaining to this problem. Thank you.